In this assignment, our team designed an offensive agent using Monte-Carlo tree search and value iteration, and the defensive agent using heuristic search. For offensive agent, we started with value iteration and further improved to Monte-Carlo tree search due to some limitations of value iteration. We will discuss a comparison in later section. We used heuristic to get to the border. Value iteration begins when offensive agent enters the opponent's area. For each step, we iterate 30 times and update the nearest 30 cells around the current location. Reward is calculated by feature times weight. Next action is chosen from max value. At the initial position, we use a random food as goal and follow the minimum path to goal. Feature value and weight will vary according to different mode. Our features include on defense, distance to food, distance to ghost, current score, and if the cell contains capsule. Our three different modes are on defense, on attack, and go scared. When on defense mode, Pacman can go back home to unload carrying food after eating one food. We set weight for being Pacman 0. With this mode, our agent can still steal food from the opponents even when opponent's entrance is heavily guarded. When on attack mode, Pacman is forced to eat food in the opponent's area. Attack mode is switched on when Pacman haven't been eating any food for 20 steps. We set weight for being Pacman to Assailant. This mode makes our attacking strategy more flexible. Our agent could eat more foods when foods are compact. When on Go Scarce model, we set weight for Ghost to positive and weight being Pacman 0.
One of the main challenges we may face in this approach is our Pacman may run into the dead end. It will be an issue if it is chasing by the ghost and end up being caught by the ghost. Our solution for this challenge is that we recursively simulate 9 further steps to avoid Pacman run into it. The challenge is oscillations may occur and may increase the risk of catching by the ghost. In order to avoid this, we have implemented a method called avoid stuck to avoid the Pacman repeating to go back and forward. One disadvantage of value iteration algorithm is that we may need to iterate more times in order to cover all possible steps in the maps to retrieve the most optimal actions for the Pacman. Therefore, 30 iterations is not enough to filter all possible risky actions. However, if we increase the number of iterations, the trade-off of this is that the state space may also increase at the same time. For this and get a better performance, Monte-Carlo tree search is implemented. Instead of using value iterations, we predict next 12 steps and simulated 24 times for each action to make. And all other functions remain the same as before, such as reward is still determined by the multiplication of feature and weight. The next action is also chosen by the maximum result.
For offensive, some future improvements are be more adaptive to different maps as sometimes we can't find the right entry. Finally, we want to be more flexible when we are attacking, as now we are more conservative. Our defensive team use heuristic function in different modes in order to achieve a good action when defending. There are 3 modes, which are no invaders mode, which is when there's no invaders in our area. Finding invader mode is when there's a Pacman in our area but the position is unknown. The untrace mode is when our goals can detect this an invader and also the position is not. For no invader mode, we calculate the minimum distance to the center point at the start of the game as our heuristics. To ensure our goals do not go past the border, we remove the action which will turn our goals to Pacman. To ensure we can catch opponent quickly, we will oscillate at the midpoint. Finding invader mode will try to detect if there's a food being eaten. If so, it will use the food eaten as target position and minimum distance is calculated. If there's no food eaten, our goals will find a random food as target, which gives it some chance to detect the opponent. Untrace mode will turn on when there's a Pacman in our area and we know its position. Therefore, the minimum distance to the opponent Pacman is used. Some future improvements are as if we are one step away or few steps away from the opponent, we only have small probability that we can catch it. As a result, some future improvements are combined both offensive and defensive agent together when we are unavailable to catch the opponents. Thank you for listening.